Welcome to Make Me Data Literate, the podcast that makes data intelligible from the Australian Data Science Education Institute. We're on a mission to make the whole world data literate. I'm your host, Dr. Linda McIver, and every week I'll interview someone with a wild and wonderful relationship to data. Let's see what we can find out. Hello, and thank you so much for joining us for another episode of Make Me Data Literate. I'm really excited today. We've got another change of pace. We've gone from economics to ecology, and today we're looking at neuroscience with Nic Price. Welcome, Nic. Thanks so much for coming.
Hi, Linda. Thanks very much for having me along.
It's awesome. I'm really excited about this one. So can you tell us, who are you and what do you do?
Who am I? Well, normally I start by saying that I'm a neuroscientist. So I am somebody who likes brains. Uh, Formally, I guess, I'm an associate professor at Monash University. I'm deputy head of the neuroscience program there. And I'm also an academic, which means that in addition to doing research, I have a teaching position. So I teach neuroscience to scientists, biomedical scientists, and medical students.
Awesome. I know that neuroscience is heavily data focused, so I'm really interested to get into that in a moment. But first, I want to ask you what you had to learn to do your work, particularly from a data point of view. Was there anything missing from your formal education? Did you have to kind of self-teach yourself a bunch of stuff?
What did I have to learn? So, kind of everything and nothing. By which I mean, there's a lot of neuroscience is very diverse, and so there's a lot of different avenues that people take to get into it. So the pathway that I took was to do actually electronic engineering along with physiology. So they're my formal kind of undergraduate degrees. So that taught me a lot of things about control systems, about information theory, about statistics. Um, but it didn't really teach me about uh, people and organizing data and psychology and behavioral psychology. And so lots of things were sort of missing. Um, and yeah, so my research ends up requiring really diverse skills, and this is one of the real challenges that I have, both kind of personally and for recruiting people into the lab. We just need this mixture of people who are happy sitting in front of a computer doing coding, doing statistics, but also who are happy doing surgery and understanding how anesthetics work and playing with the biology. And so it's this real interface between computers and biology.
That's a really insane mix of skills.
It is, yeah, it is hard because I guess people who are interested in large data sets and have good coding skills tend not to have a background in biology or be interested in brains. But what we do find is that a lot of people with engineering backgrounds see the brain as a massive engineering problem, either to understand or to kind of tinker with and improve, or to fix. And so there are quite a lot of computer and electronic engineers who find themselves ending up in neuroscience.
That's really interesting. Do you see the brain as an engineering problem? You've got the engineering and the physiological background.
So I guess there's a bit of history to that. There's sort of this trope in neuroscience where whatever the latest technology of the day is, the brain gets stated as being sort of a souped up version of that.
Right. It's
So
like a neural network.
well, going back thousands of years, that means, oh, the brain is just a very fancy hydraulic system. And then the brain became, oh, it's a very fancy sort of steam engine equivalent. Um, and then the computer analogy obviously took hold 50 plus years ago. And then sort of the analogy of a networked system of, oh, it's more complex than the internet. And so it's a whole collection of computers. And so, given that that's our latest kind of technology, that's the sort of thing that I equate it to. It's sort of a network of a whole bunch of computers.
So you start from that as your kind of hypothesis and try to show the connections with that theory, or
Yeah, I don't know if hypothesis is the right word, but it's certainly a framework that guides our thinking. So the brain contains a typical human brain contains around 100 billion individual neurons. And neurons are the fundamental cells that make up the brain. uh, and they're all massively interconnected. So you can have one neuron connected to up to 100,000 other neurons.
Wow.
So you take those two numbers, 100 billion neurons, each with connections to potentially 100,000 other neurons, and you've just got a massive different connections. And that's where the sort of internet analogy comes in. And that's the challenge for our understanding. We want to understand how individual neurons sort of function, how they represent information, but also how they communicate information to other neurons, and then how networks of neurons, say hundreds or thousands or millions of neurons at a time, actually work together to lead to the things that we associate with brain function, like conscious perception and controlling behavior and our emotions and that kind of thing. So big problems.
It fascinates me that we don't have any tech that's really complex enough to equate to the brain yet, and also we don't have anything that operates at the insane level of energy efficiency. You know, if you look at the latest supercomputers, they're massive and insanely complex and have masses of processors, but they're still not a patch on the brain, and they use many orders of magnitude more power to do less, really.
Yeah, yeah. And there's the idea of neuromorphic computing, where engineers are essentially trying to take design principles from the brain and use those to actually generate sort of different approaches to solving computer problems. Uh, but as you say, they involve many orders of, but you can't power them on peanut butter and jam sandwiches. It's yeah.
I look forward to the day we'll be feeding our supercomputers sandwiches.
Yeah.
That sounds like fun. Is there, you use a lot of data in your work, and obviously you have to communicate as a lecturer and communicate about your work. Is there something that you wish everybody knew about data, that if you could just, people came in with this base understanding of something, it would change everything or make everything easier for you?
Uh, yeah, so I've kind of got two sort of ways of answering that, I guess. So I guess the reason that we acquire data is because we have questions, and so data helps us make decisions, I guess. But we're humans, we hope, and so our decisions aren't ever based purely on data; they're based on emotion, and I use the word emotion there as sort of a proxy for politics, family, religion, just habits, what things that you think will make you happy. So whenever we're making a decision, there's this kind of balance between what the data is telling us, and hopefully that's just telling us one thing if it's simple enough, but then the emotional side of things. So I guess what I wish people knew about data is that anytime they're making a decision, it's this balance. And so I think people like me probably defer too much to data and don't care enough about emotions. But I think most people actually defer too much to emotion and don't listen to the data enough. Um, so, yeah, I think data on its own is not the only thing. So yeah, data alone doesn't tell a story, I guess is the thing.
Yeah, I think that's a really important point. And I think it fascinates me. I have friends who believe that they're strictly rational, that all the decisions are based on data. But your point that we don't do that, as human beings, we don't reason objectively in a purely data space. We are inevitably affected by our emotions, even when we're engineers, and computer
Yes, yeah,
scientists.
and I'm a neuroscientist, so one of the things that I'm interested in is how we make decisions,
Hmm.
and how we use data to make those decisions. But I know that I will have my own biases, and so then the challenge is, can we actually sufficiently overcome those biases to interpret the data that we have?
Yeah, I'm fascinated by the result that came out some years ago that found that people who know that they're biased, who admit that they're biased, are actually less biased than people who say that they're not biased. And it's because if you know you're biased, which we all are, we are inevitably biased, then
Mm,
if you know
yeah.
you're biased, you can actually tackle that. But if you don't admit that you're biased, then you're not tackling your biases, and so they run away from
Yeah,
you.
and then even so I was talking with my father-in-law on the weekend, who is he was formerly a Tibetan monk.
Wow.
And so he comes at the brain and the mind from just a completely different perspective to me. But we were talking about the idea of post-diction. So everybody knows what a prediction is. So you can, based on everything that you've experienced up until now, you can predict that something is going to happen in the future. But post-diction is actually where you see an event from the past and you kind of rationalize it, and you almost say, well, I expected that was going to happen because of these reasons, and you fool yourself into thinking or believing that you knew that was going to happen and the reasons that it was going to happen. And so it's this kind of post hoc prediction or post diction. Yeah.
That it relates to the concept that I think it was Jonathan Haidt referred to it as the rider and the elephant, that the conscious brain is the rider and the subconscious is the elephant, and the brain's going to turn, the elephant's going to turn left whether you like it or not, and the conscious brain then goes, oh, I meant that.
I
that
meant
was
that exactly.
that
That
was
is
me.
that is exactly the yeah. Yeah,
I love
exactly
that
the idea.
analogy. It's very powerful. I like the idea of post diction too. I think that's
Yeah.
something we need to be a lot more aware of. What are the worst data mistakes you've seen?
The worst data mistakes that I've seen. So I guess it's I guess it's very common that people want to tell stories with data, and well, people want to tell stories. Humans are storytellers, and data often makes telling a good story difficult, and so anecdotes become the replacement for data. So these kind of one-off examples of something that fits the story that we want to tell, and
Mm.
politicians are the classic example of this, because it's much easier to appeal to, say, a single sick person than a collection of unhealthy people across society. You can put a face on something. So I feel like that way of skewing a story based on an anecdote that could be an outlier or could not be representative of your data set is sort of the most common thing that we sort of experience in society about data literacy. And it's people who are aware of that and aware of the importance of emotion and then manipulate it.
Do you
So
ever find this?
I don't know if that is a mistake or if that is like a deliberate uh, you know deliberate manipulation, I guess,
Yeah,
of the way you
we've
report data.
skipped a question there. We've gone straight to the
Yeah,
deliberate misuse, and it's interesting to me that people, a lot of in many of the episodes I've recorded, people do that. They go straight to the deliberate misuse, and I think those ones are the ones that really stand out because they're outrageous and deliberately manipulative, and so they're really the sort of burning examples
yeah.
that are hard to look past. But are there some sort of mistakes that you've seen that you would say are not, not deliberate, but perhaps are failure to understand data?
Um, I think, well, so from the perspective of somebody who sets assignments and attempts to teach students, uh, I think there's always a perception that there has to be a correct answer and a simple answer and a significant difference and a easily reportable effect. And so in a lot of my assessments, I give people either real world data or extremely noisy data where it's actually really challenging to work out sort of what the truth is, I guess. And so people will come up with all sorts of manipulations of their analysis so that they can find, say, a significant difference or a meaningful effect that they can then write about. And they don't look at what's actually there. They just have it in their mind that they have to find something significant, and
I
that's very common.
you, you can see, but our listeners can't, that I'm nodding really hard, and I did a tiny fist pump when you first said, people think that there has to be a right answer. That's one of the things that I think is incredibly important, and why the work that I do with the Australian Data Science Education Institute is very much focused on making sure that kids are working with real data, and they don't know, what the answer is. They don't even know if there's an answer, so they have to evaluate their own work as well as thinking about the quality of the data and what the issues might be with it, because we don't normally teach it that way. You look at a standard maths textbook and you get perfect curves and straight lines and all the kinds of things you just never see in real data.
Yeah. So I guess in certainly in tertiary education, I'm not sure if this is probably true as well in secondary and primary education, but I think a lot of students have the perspective that science is about facts and textbooks and these things that are sort of just known. We hold these truths to be immutable
Yep.
sort of thing. And what textbooks almost always hide is the nature of experimentation, the subjective choices that go into designing an experiment, the difficult data that people have had to sort of massage or selectively ignore or come up with justifications for the way that they've treated it. And so, real science, I think, as soon as you have numbers involved, things tend to get messy. And this is maybe I'm overgeneralizing. This is definitely true in biology because there is a lot of variability in biology. Maybe less
Mm.
so in chemistry and physics. Uh, but
I think it's more true than you might think,
mm,
across all of the fields, and I think it's a really significant flaw with the way we teach science, because we do teach science as a matter of facts and known processes and predictable outcomes, and that's not science at all.
mm,
um,
yeah,
and our exams are full of, give us all of these facts about biology and these facts about chemistry, and apply these processes and get this predictable outcome, and it's not teaching us about uncertainty. And I think that also leads us to the problem of, when you're facing something like climate change or a pandemic, that as our understanding grows, the story that we're telling about the situation changes. For example, COVID is airborne, not droplet spread. um, and science deniers will go, oh, see, you changing your tune, that means you're wrong. And it's like, no, that's science doing what it's supposed to do. That's the way it's supposed to work, but it's not the way we teach it.
yeah. I think a lot of my colleagues are very comfortable with uncertainty. They're very comfortable with the idea that uh, whatever we sort of measure, analyze, look at, there's going to be just a lot of variability in it. And that's not the way things tend to be presented in textbooks or in the media. And so I think being able to cope with that uncertainty and sort of lean into that uncertainty is something that I try to encourage, at least in all of the honor students and above that I interact with.
That's awesome. I'm really pleased to hear that. It's the one thing that above all else, if I teach my if I get nothing else across through the work that I do with ADSI, just getting the idea across that you don't know if your answer's correct, and there may not be such a thing as a correct answer, and you need to really think about it and evaluate it and think about.
Which is hard though, because we crave certainty, and
Yeah.
uncertainty is a form of stressor, and
Yes, it is.
that's not necessarily a good thing. But I think we can be uncertain about our data or what story the data is able to tell.
Yes. Yeah, that's a as you say, it's something we need to learn, and something we have to get comfortable with in order to make progress, I think. Um, do you have a way that you spot? You said we're talking before about data being misused and stories, the wrong story being told. Do you have things that you look for? How do you spot it when data is misused?
Oh, so I am not really aware of data being misused in kind of the scientific field that I work in, fortunately.
Mm.
Um, certainly, there's data presentation styles that might be missing or not telling the full story, or where I'd like to have more access to the raw data. But at least in the research side of things, I'm not aware of sort of data being sort of misused, I guess, or necessarily poorly presented. I think maybe it's more in the popular media reporting. That's it's the challenge of being a journalist. You've got to tell something very efficiently, in a limited number of words. So it's a different challenge there. But I think sometimes the details that I would like to see just get completely left out.
Yeah, it's I guess that's one of the tricks, isn't it? Looking for the specifics, looking for the details, and if the details aren't presented, is there a link to, can you follow it up to the source and figure out what the details are?
Yeah, so I guess I could give a specific example. Well, I could probably give endless examples. But you think about something like house prices, which just always seems to be in the media, and what typically gets reported is a median house price. So is that useful to anybody who's really looking at buying a house or who's trying to make a decision about housing? Not really, because that's just this value that doesn't really capture the complexity of the distribution. And so, what you need to know is the variability in that distribution, or how wide it is, and whether you're looking at something at the top end of town or in a further out suburb. And I guess sports analogies as well. Like sports is all this really complex way of essentially ranking individuals or ranking teams. Um, and so there's but people get distracted by kind of irrelevant statistics. I think it's like, oh, this team last won the grand final like 35 years ago, and they were kicking west and they were wearing green jumpers or whatever. It's like most of that is irrelevant, irrelevant things. They're factoids. um, so working out what
Yeah,
what the actual important data is another challenge.
it's an interesting one because often the important data is not the data that's most attractive. It's not the most clickbaity or the most soundbitey, not the thing that there seems to be some data that's just, it fits easily into our heads, or it's easy to believe, or it's somehow satisfying. Particularly if it panders to our prejudices.
Yeah, yeah.
um,
Yeah, I think earlier you asked a question about what was missing from my formal education. I might have skipped that, but I think that idea of how to actually ask questions, or what are the meaningful questions to ask, is something that definitely I feel like was missing from my education. I'm continually now trying to work out what are the questions that are worth asking, and I'm not quite sure how you train that into people, because this is now my
it's
challenge. How do I train people how to ask questions, and how to ask questions that are worth asking?
That's a really interesting one, and it fascinated me when I first started working with data with students. We used an election data set, and we had all of the votes for the Senate in the federal election. And I asked them, what questions can you ask of this data? And of course, the first thing they said was, well, you can ask it which is the best party. And I would kind of sigh and go, well, no, that's not reflected in the data, at least from my perspective. But then you have that whole question, what do you mean by best? We define best, and they're like, well, it's who got the most votes. And I'm like, I don't think so. I'm a member of the Greens, so I don't see that in the data at all. And that thing about whether you can ask qualitative or quantitative questions, and what the data can tell you and what it can't tell you is, we don't teach that anywhere. It's one of the key things I did when I started ADSI, is build that into the projects and go, what can this data tell us and what can't it tell us? And just to understand that is, I think, a really important step before you even get to the what's it worth asking. What do we really want to know? What are the useful things to explore?
Yeah, yeah. I guess from the hard nosed data scientist point of view, you're looking for actionable insights, but that's just kind of kicking the definition can down the road, I guess, because what's an actionable insight?
Yeah.
But something that you can monetize or change lives with, or have positive outcomes for society, or often in my case, as a well, one of my hats is as a discovery researcher, just trying to understand things. that's the end goal. Is just, can we have a better understanding of this? The
Something that
applications are important and will come next.
something that progresses our knowledge of a topic or our understanding of a topic.
Yeah.
And it's increasingly difficult to get funding for those sort of non-specific, or we just want to understand it rather than we want to monetize it, can be a challenge in grant applications and things.
I think that's I think that is true, yes. But fortunately, there is still funding available for that kind of discovery-based research, um, and ultimately showing that there is the possibility of an outcome that's, I, it doesn't have to be monetizable, but ideally it should be benefiting society.
Yep,
Um, I think that's very important as well.
that makes sense. What's the first question you ask when you look at graphs in the media?
When I look at graphs in the media, uh, I guess I want to know what is the question. I've actually got that on a whiteboard in my office at the very top. Just what is the question, and can
Nice.
we answer it? um, so yeah, as in, I'm trying to think of a specific example here. But I guess, am I seeing the raw data is really important to me, or am I seeing some kind of interpreted version of the raw data?
Hmm.
Uh, because if I'm not seeing the raw data, then I need to trust how it has been kind of processed. So that's one
I,
level of abstraction, and the kind of more abstract or more processed the form of the data, the harder it is to interpret, I
mm.
think, and the harder it is to trust it as well.
Well, I think that's it's highlighted by the various examples of medical imaging, and we tend to think of an MRI as being like an X-ray, and that it's a photo of what's in your brain, but or whichever part of the body they're looking at. But it's actually this complex post-produced
Yeah, absolutely. There's a huge
algorithm.
amount of computer processing goes into it. Yeah,
Yeah, and it's not a photo at all. It's an interpreted visualization of the data, I suppose.
yeah,
And
yeah,
if you look back at the original functional MRI um, studies where they found that they did an fMRI on a dead salmon and found that it produced results. um,
yeah. So that was an interesting example of just, I guess, the danger of repeating noisy sampling multiple times. So if you sample from a noisy distribution and you apply standard statistics to it, almost, well, essentially by definition, you will find sort of something that appears to be significant, even though it's not 5% of the time, if you set that to be your threshold for significance. So if you
yeah,
repeat that test thousands of times, then you are going to find something that seems to be significant. Uh,
that comes back again to that question of rational skepticism, doesn't it? Where you have to challenge your results and ask yourself whether what you've got is actually what you think you've got. And
yeah, this is one of the things that I think my students might really hate me for, because whenever we get a positive or an exciting result, the first thing we do is try to break it. We try to
yes,
find all of the possible explanations for why we might have done something stupid, and tick them all off as like, nope, we didn't do that, we didn't do that, we didn't do that. Um, and maybe this is why I'm not as high profile a researcher as I could be, because I'd be publishing a lot more wacky results if we hadn't done those checks.
I did a little happy dance in my seat when you said that, because it's it's so important that this tendency to produce a result and publish it and move on is massive in the data science industry, and
Mm.
really very very dangerous.
Yeah. So I mean, I see this at every level that I work with as well, because I can give my undergraduates a big data set and say, oh, find tell me what you find in this, or just try and answer this very specific question. And ultimately, it comes down to using some kind of tool, so some kind of computer program or statistical tool, and they will get an answer out of it. But because you can generally press a button on a computer and it will give you an answer, but working out if it's an appropriate answer is a challenge. And then my students then start learning how to program. And again, if your program runs, you will get an answer.
Yep.
But there's many ways that you can get a program that spits out an answer that is not meaningful. So yeah, we put a lot of effort into kind of debugging and pair coding and trying to work through ways to just find mistakes that we all make.
That's fantastic. I love that assumption that there are going to be mistakes. That, as you say, we all make them. The danger is to assume that there's no mistakes until something pops up to prove otherwise, and that doesn't lead to good solid results and actual progress in understanding. It leads more to the reproducibility crisis.
Yeah, yeah. And again, like it's not something that I'm actively sort of teaching into people, because you sort of only encounter it when you make those mistakes and have them pointed out to you. And in the
Yeah.
context of an assessment, students wouldn't cope with that if if they're like getting something wrong like most of the time and it gets sent back. And yeah, so there's awkwardness is in how we sort of get people to exposed to making these mistakes in a kind of safe way before they're out
Yes.
sort of analyzing real world data or trying to actually make decisions based on their analysis.
And that raises really important questions about our assessment, doesn't it? And if you can build in, and it's time consuming and potentially more expensive to do it this way, but if you build into the assessment, have you rigorously tested your results, rather than this, what we often do in schools, at least, as we give marks for the right answer, um, rather than giving marks for, well, how can you, why are you sure that this is the right answer?
Yes, yeah,
Have you tested it? You know can you really um, show us that you've evaluated this really carefully?
yeah, yeah. That's a challenge. And look, my a lot of my students in who are interested in neuroscience are not actually that interested in data based questions,
Yeah.
because they're coming into it from the biology route.
Hmm.
So they haven't ever done any programming. They haven't ever played with any data sets that have more than six numbers in them. So this is a real challenge.
Do you find it easier to teach people the biology or the tech?
Uh, Definitely easier to teach the biology. Um, so yeah, it's harder, I think, to pick up good sort of coding habits, programming habits. I'm talking now about sort of honors students and above.
Yeah.
Um, but yeah, people will progress much faster if they can already code when they come to join my group.
Yep. Which is one of the reasons we need to be teaching it so much earlier. Just one.
Yeah, yeah. Otherwise, they kind of spin their wheels for a year or two, learning how to just handle data sets.
Yeah.
But I guess on the other hand, some of my really successful students have not had any coding experience previously. And so, as long as they're logical minded, and they're not afraid of data, and they don't mind, oh, the pain and suffering, and then joy that comes of learning to code, then they can do great things in relatively short amounts of time.
It's about motivation, isn't it? I think anyone can learn to code if they really have good reason to.
Yeah, and if they have a problem that motivates them,
Yeah,
I
exactly.
think the idea of just sort of learning to code is a challenging one,
Mm.
because if you don't have a question that you can sort of hang on to it, that you're trying to solve, that keeps you motivated, then it will be just too frustrating.
That's I'm going to put that in my next book. I mean, it's exactly why I do what I do, and it's what I figured out when I started teaching using data science instead of teaching programming using toys. When you teach it using toys, the kids just aren't interested. But when you teach it, as a tool they can use to solve a problem that they find interesting and meaningful, then their motivation is enough to overcome those frustrations and those challenges.
Wait, I lost you there. They're not interested in learning things about programming toys. Or do you mean
Yeah, they
like
don't.
toy concepts?
No, as in they don't want to. So we used to teach code using robots and
Yeah.
drawing pretty pictures and stuff, and they just weren't interested in that at all. But when we started teaching the same programming concepts using real data sets, so instead of making robots push each other out of circles, they were extracting data from files and processing it and making visualizations and stuff.
Right.
Suddenly they could see the point.
Right. Okay. I guess for me the equivalent was Logo, the turtle.
Yeah, see, I
Uh,
loved the turtle. I loved it, but a lot of kids don't.
wait, is that still a thing?
Yeah. You can program with the turtle in Python now.
Oh, okay, right. I mean, I kind of enjoyed it, but I just didn't see the point.
Yeah.
There was just this stupid triangle moving around on a green screen, and
See, that's how we lose kids
mm,
because we tell them it's fun. They don't find it fun. So
yeah,
why
and
would they
so
persist?
I I did one unit of coding when I was at university, and absolutely hated it, and had no interest in doing it at all, and then got into my honors year where I was actually working in a lab, and I was like, oh, I wish I'd listened in coding, and I wish I'd done more of this because now it's really useful, and now I need it to be able to answer these questions that I'm asking. Um, and
So
so,
did you have to teach yourself?
and then I had to teach myself. Yeah, yeah. Um, with a little bit of help from my supervisor, but not much. So yeah, that was a missed opportunity because yeah, but it comes back to our original point, I guess, that once it became interesting,
Yep.
and I had an actual problem that I wanted to solve, then it was worth doing.
I hear so many scientists say that not having learnt coding really strongly early on delayed their research and really made things much more difficult. But we still don't have coding as a core part of a science degree. Imagine if we
Hmm.
if we had programming in a science degree, but programming for scientific problems rather than programming for the sake of programming. I think you get some interesting outcomes.
Yeah, I think that would be useful. I wouldn't want to be responsible for teaching it, um, but I think it would be. I think it would be really helpful. Yeah.
Yeah, I think so too. What is it that excites you about data?
Um, it means I've done an experiment recently. If I've got data, um, so I think if I've got data that I'm sort of interrogating, that I'm trying to pull trends out of, then it means that I'm not yet disappointed. Is that a too negative view of looking at the world? Because as long as I have data, it means I haven't analyzed it yet. And so I have a hypothesis, I've got a question that I'm trying to answer, and so I'm sort of, it enables me to move somewhere. Um, I keep coming back to storytelling. It means that I've got the introduction to the story, and I'm trying to develop it. So that's for me kind of the most exciting period of sort of the scientific process is that period where you've kind of mid experiment, you've got some data, you're trying to make sense of it, and that will then feed back and help inform the next experiment and your next set of data collection.
It's that potential. I love
Yeah,
that you
it's
keep.
the potential. Yeah, that's much more positive than saying there's not disappointment yet.
I love that you keep coming back to storytelling, and it comes up so often in this podcast because I think data is really not useful to us unless we can tell stories with it. Um, you know,
Yeah. So
unless we can communicate it and make it meaningful for people, then why have it?
yeah, yeah. So I think I'm interested in how the brain makes decisions, and so yeah, having a good representation of data in the brain is critical for that. Yeah.
Thank you so much for coming on today. This has just been so many times where I've been, fist pumping and going, yes, and that's in my book, and yes, at that point, and yes. And I didn't set you up with it at all. It just happened organically, which is very satisfying to me.
Excellent. Thanks you very much. Um, I did have one. Can I squeeze in one last pithy statement because
Please.
I just remembered that I wanted to say this. So a lot of people think that they don't like statistics, and I think as we were talking about with coding, it's because statistics is taught in a really abstract and dry kind of way. Um, but your brain loves statistics. So your brain is always trying to do correlations. It's trying to match up one event with another and one event with another. And so correlation is a really fundamental aspect of statistics. But your brain is also always trying to work out what is the distribution of your environment. So, for example, if you're sitting in a dimly lit room, your brain adapts to the statistics of the lighting in that environment or the sound in that environment. And you walk outside into bright sunshine and there's traffic, and you because you've adapted to like that quiet indoor environment, say it now seems really bright outside and it seems really noisy. But then you adapt to the statistics of the outside environment. So your brain's continually recalibrating to these statistics. It loves them. It's how it finds outliers and things that are meaningful and things that are important. And so I kind of figure if our brains love statistics, then we overall, who are defined by our brains, should also sort of get into statistics and data and these things.
I love that. So the brain naturally loves statistics, and if we don't love statistics, we just haven't met them in the right way.
Exactly. Yeah. That's a good way to put it.
That's beautiful. That's a wonderful note to end on. Thanks so
Yeah.
much, Nic. This has been
Thank you,
fabulous.
Linda.
Thanks for listening to Make Me Data Literate. You can support the work of the Australian Data Science Education Institute at givenow.com.au/ADSEI. Tune in next time for more conversations with amazing data experts.